In this exercise, you're basically asked to construct a 99% confidence interval for the population mean using the sample of 5 random values selected. So when you're constructing a confidence interval, the formula for a confidence interval for a population mean is found by taking your sample average, x bar, plus or minus what's called your margin of error. Your margin of error is determined by taking t star, that's called your critical value in the t distribution, and multiplying that by the standard error, which is found by calculating the sample standard deviation divided by the square root of n. So first, the mean is found easily by taking each value of your 5 values in your random sample, adding them up, and dividing by 5. So when I add up the values 9, 5, 4, 6, 8, and 4, I get a total sum of 36. When I divide by 5, divide by 6 because I have 6 numbers in that set of data, I get an average of 6. So my sample average, or x bar, is equal to 6. So now my t star. That's my critical value, and I made a video of this previously. My degrees of freedom, of course, are 6 minus 1, which would be 5. So if I go to my table of critical values for the t distribution, because this is about means, where we don't know the population standard deviation, I go to the column that has a label of 99% confidence at the bottom of it, and I go all the way up to the row whose degrees of freedom are labeled as 5. And I get a critical value, that's called my t star, of 4.032. Now, I don't know if your table rounds to 3 digits after the decimal point or 4 digits after the decimal point. I'll round to 3 digits after the decimal point. So I have my sample average, I have my critical value t star. Now what I need is my sample standard deviation. Now, standard deviation can be computed using your JMP software, but it could also be computed by hand. And I might do this a little bit differently than your software that you're using is showing you how to do this, but I'm going to show you how I demonstrate calculating the sample standard deviation to students on my next slide. So standard deviation measures average spread away from the mean. So the first thing we have to do is determine how far away from the mean are each of the values of our random sample. So our random sample has the values 9, 5, 4, 6, 8, and 4. We know we have to work from the inside out of a formula. So if there's an operation in parentheses, we need to do what's in the parentheses first. So we need to figure out how different each value of x is from the mean we just calculated, which is 6. So our first value of x is 9. 9 minus 6 is 3. Our next value of x is 5. 5 minus 6 is negative 1. Then 4 minus 6 is negative 2. Then 6 minus 6 is 0. 8 minus 6 is 2. And 4 minus 6 is negative 2. We call those our deviations from the mean. Well, the next thing we noticed in the formula is that those deviations need to be squared. So I need to take those values that I just got in the previous column and square them. And remember, any number squared will never be negative. So 3 squared is 9. Negative 1 squared, the same as negative 1 times negative 1 is 1. Negative 2 squared is 4. 0 squared is 0. 2 squared is 4, and negative 2 squared is 4. So now the formula says take all of those deviations from the mean squared and add them up. So what I have to do is take all of the numbers that I have there in green and add them up. The sum of all those deviations squared is 22. So that is the numerator portion of this formula. Then I need to divide by one fewer than the number of observations in my data set. Well, I had 6 observations in my data set. One fewer than that would be 5. If I divide 22 by 5, I have what's called the variance. It's also denoted S squared. But I'm interested in the standard deviation. So I need to take that S squared and get S. Well, to undo squaring, I need to square root. So if I take the square root of 22 over 5, I get a standard deviation of about 2.098. Now, I don't know how your program is wanting you to round that. Oh, to 4 decimal places as needed. So that would be 2.0976. Now what that basically means is in this set of 6 observations, this random sample, the average value is 6 plus or minus about 2.0976. Okay, so the average spread away from that mean of 6 is a little more than 2. Okay, so now we have all of the values necessary for our confidence interval. The formula is again there displayed in blue. Our sample average X bar was 6. Our critical value that we got from our table of critical values for the t distribution, because we're talking about means, was 4.032. We now know that the standard deviation of our sample, rounded to 4 decimal places, is 2.0976. And that needs to be divided by the square root of n. N is the sample size, so we need to divide that by the square root of 6. So if I take 6 minus 4.032 times 2.0976 divided by the square root of 6, I get the lower boundary of this 99% confidence interval, which is, I'm going to round to 4 places again. I don't know what they're going to ask you to do, but 2.5472. That's the lower boundary of my interval. If I take 6 plus my margin of error, which again is my 4.032 times my standard error, I get my upper boundary of my interval. And so that is 9.4528. If I'm interpreting this confidence interval, I can basically say that I am 99% confident that the true average of the population that this sample comes from is somewhere between 2.5472 and 9.4528.